In this class we will study about meter bridge. We have studied about V-stone bridge, and this meter bridge works on the principle of V-stone bridge. First we will see the construction of this bridge. The bridge consists of a wire, and the wire length is 1 meter. So meter bridge consists of a wire of 1 meter length. So if you can see here, there are two resistors R and S which are clamped here. This is not 5, this is S. R and S. So there is a metallic strip here which is bent at right angles here, and the two gaps are maintained, and between these two gaps we are connecting two resistors R and S. So R and S are connected between the two gaps. Now this end point wherein A and C, which is the end points of this wire of length L, is connected to a battery or to a cell. And now you see a point B here. It is the midway between the two gaps, and this to this point B we are connecting a galvanometer. The other end of the galvanometer is connected to a jockey. If you see here, the other end of this galvanometer is connected to a jockey. So this jockey is a metallic rod, and its end is actually connected to a knife edge, which we can slide over the wire. So this jockey can be slided over this wire to make electrical connection. Let me tell about the construction once again. The meter bridge mainly consists of a wire of length 1 meter, and it is connected between points A and C here, and to this point also we are connecting a battery. Now R and S are two resistors which are connected between the gaps of this metallic strip, and to the midpoint between these two gaps we are connecting a galvanometer, and the other end of the galvanometer is connected to a jockey, and this jockey is a metallic rod which can be moved over this wire to make electrical connection. Now if you see this here, now I have taken a point wherein the jockey or this metallic rod is making a contact with the wire at a distance L1 centimeter from the point A. So if I rewrite this arrangement, it will look like this. This is R, yes, and this is the point B, and we have, this is actually the length L1 centimeter. So this part is length L1 centimeter, and the other part of the wire is the length of 100 minus L1 centimeter length. Okay, so this is the length wherein I have concentrated the resistance at one point, and the galvanometer is connected between these 2 points, and the cell is between this is the point A. See, you can mark this point as D, and the battery is connected like this. So you can compare it with V-stone bridge. The meter bridge works on the principle of V-stone bridge. Now let us say R is the unknown resistance whose value we want to determine. Let R is the unknown resistance. Let R is the unknown resistance whose value we want to determine. Now let us say S is the standard known resistance. S as the standard known resistance. And now if you see here in this figure, the jockey is connected to point D, and let this point D is at a distance L1 centimeter from the end A. Let D is a point at a distance L1 centimeter from the end A. Now the portion AD has a length of L1 centimeter. Let the resistance RCM is the resistance per unit centimeter. Let RCM is the resistance per unit centimeter. RCM is the resistance per unit centimeter. So the portion AD, now the resistance of portion AD is equal to the length is L1 and the resistance is RCM, so it is RCM into L1. RCM into L1. RCM into L1. Into L1. Now let us say the resistance of portion. Now I'll write here only the resistance portion DC is equal to, the length of the wire is 100 centimeter or 1 meter. So the remaining length DC is 100 minus L1. Therefore the resistance is RCM into RCM into 100 minus L1. Now the 4 arms, if you consider here A, B, B, C, C, D and D, A, as shown in this figure, actually represents 4 arms of the V-stone bridge, and battery is connected between the points A and C. Now if you move this jockey over this wire, there will be one point wherein the galvanometer deflection will be 0, or the current flowing through the galvanometer is 0, or we get a null deflection. So let us assume that T is the point where the galvanometer shows no deflection or the galvanometer current is 0. So we have already considered this distance as L1 from AD, and the distance CD is 100 minus L1. So we can write here that D is also a point wherein the galvanometer current is 0. Point let D is the point of the jockey, where the galvanometer shows no deflection. So we can say that under this condition the bridge is under balance condition. Therefore we can write using P by Q is R by S, bridge balanced condition. R by S is equal to, if you see in this figure, R by S is equal to L1 divided by 100 minus L1 into RCM. R by S is equal to L1 into RCM divided by 100 minus L1 into RCM. The RCM will get cancelled. Therefore R by S is equal to L1 divided by 100 minus L1, or RS equal to S into L1 divided by 100 minus L1. L1 divided by 100 minus L1. This is how we can calculate the unknown resistance using this meter bridge. If R is the unknown resistance, by using Wheatstone bridge principle, we can get the balance condition, and we apply the balance condition equation, we can easily find out the value of unknown resistance R. Now in the next class we will see some more problems based on this bridge.